color filters are a powerful tool to manipulate images. Photographers and filmmakers use them to give their work an artistic look, digital painters use blending modes to change the color palette of their work, and colorblindness simulators show how people with color vision deficiencies see the world. However, understanding how color filters work can be challenging. Before and after images only show how a filter acts on one image at a time, making it difficult to predict how it will affect other images. And yet, color grading experts know how to look at color filters to analyze them and understand how they behave. This work aims to help people see filters like these experts. Inspired by Charles Goodwin's work on professional vision, we developed ColorField, a web application that illustrates what a color filter does by representing it as a vector field and enabling interactive exploration of the filter's effect on different colors. First, the system shows an image before and after the filter is applied. To explore how the filter affects individual colors, it also displays a sample color before and after the filter is applied. The user can select the sample color by clicking on an image, or by moving it on the color spectrum below. The left chart represents the lightness and saturation for a fixed hue, while the chart on the right represents lightness and hue at a fixed saturation. The result of the sample color is represented by a diamond on the spectrum. This filter simply increases the image's lightness. Therefore, the diamond is always above the sample color. By showing how colors change in the spectrum, ColorField visually represents filters as a change in color using the vocabulary of experts. To help users speak this language, the system also uses text to describe changes in the sample color. Instead of sampling every color to understand the filter, we can enable the field to see how the filter behaves in general. Using the intensity slider, we can see how colors are affected as the filter is brought in. Here, all of the colors move up. Real filters are more complex because they affect different colors differently. In this case, we can see at a glance that colors gravitate towards red and orange, making the image warmer. Note that the text now describes changes in terms of hue, saturation, and lightness. To make the color field more manageable, the user can select regions of the color space to focus on. These selections were chosen based on the terminology that color grading experts commonly use. For this filter, we can see that it changes skin tone significantly. The last section highlights the spectrum based on the colors in the image. This helps the user focus on how the filter affects those colors. It also helps users understand the color content of their image. This one has lots of saturated colors, while this one only has 2 hues and almost no saturated colors. ColorField uses a single representation to illustrate the concepts that color grading professionals use, and therefore helps its users see like experts. Since ColorField can represent any color filter, it can be used for more than color grading. For example, blending modes are usually explained either as a mathematical function or with an example image. Here, the images have a solid gray overlay with different blending modes. They clearly all result in a brighter image, but without an expert's eye, it's difficult to describe how they differ. With ColorField, we can see that screen mostly brightens the image, lighten makes colors gray, and color dodge saturates midtones. Furthermore, colorblindness simulators, in this case for protonomy, are another type of color filter. Notice that colors gravitate towards blue and orange. This explains why these colors are considered safe to design with. According to the simulation, they are perceived the same way by people with protonomy as by people with normal chromatic vision. ColorField reveals the subtleties of color vision deficiencies, and therefore helps users understand the difference between types of colorblindness. We ran a study with 5 novices and 4 experts in photography to see how ColorField impacted their ability to analyze color filters. Participants leveraged ColorField for spatial reasoning. Here, the participant is moving their mouse along the salient regions of the field. Here, the participant uses the intensity slider to animate the field and see how the filter affects all colors. He later emphasized that this helped him visualize how the filter works more generally. Experts liked using ColorField to confirm their intuition.
Yeah, increasing in saturation. Yeah, so I think that's kind of what I'm seeing, and this helps reinforce that.
This was also made clear when we withheld ColorField for the last task.
Oh no. To be honest, it was nice having that to confirm what I'm looking at.
One participant even continued to simulate the field after the visualization was removed.
You can kind of tell that I'm pretending like I'm looking at the color field right now.
We presented ColorField, a system that helps people see and understand color filters like color grading experts. We showed that it can also be used to explain how other types of color filters work. This work suggests that HCI can learn from the professional vision of experts to design novel representations of complex domains. Thank you.